G'day, Lockie here. So this is episode 2 in a series I was calling uh, Kubernetes 1.7 Feature Spotlight. And today I'm going to take a look at dynamic admission control. So there's been a lot of great material come out over the last week or so about initializers, and I thought it might be worth just taking a couple of minutes to go through what initializers are and what feature they actually fall under in Kubernetes 1.7. So initializers are part of dynamic admission control. So if you remember in prior versions of Kubernetes, admission controllers were plugins that you would enable when you started an API server. So they're actually flags on the API server. And these plugins, these admission controller plugins, were actually compiled into the source code. So that presented kind of two problems. There's some great admission controller plugins out of the box, but you weren't able to plug any more admission controllers in. And if you were to write one, they had to be upstream. So they had to go into the core. So you would have had to fork, and you would have had to get it upstreamed if the community agreed that it was a good thing to do. So for those two reasons, dynamic admission controllers have been created, and these provide a way to overcome those two obstacles. One is they're not compiled in, so you can write your own, and you don't have to set flags on the API server, so they're pluggable at runtime for any cluster. So if you have a managed Kubernetes provider and you want to use an initializer, you can without having to modify the API server flag. So it's a great way to actually extend Kubernetes without having your code upstream. So if we dig into what initializers really are and what they can do, it's really about, it's best described in use cases. So you may want to apply some policy, and there are admission controllers today that do similar things like limit ranges. We may want to put resources on pods server side, so the user doesn't have to specify them. The API server intercepts them. Once it sees that, it forwards it over to an initializer, and the initializer can modify anything of any resource before actually submitting it and accepting it as a resource. So very flexible. There's some great material out there. Kelsey put together a Kubernetes Initializer tutorial that I'm going to run through really quickly just to give you an idea of how it all hangs together. So this is great. Thanks, Kelsey. And Amit over at Google also published a blog yesterday about it as well, which is a great walkthrough. I'll put the links in the video. But for several years using Kubernetes, I wanted to put something server-side in, and Kelsey's demo actually goes and puts a sidecar container in a pod. So a user would submit using kubectl this resource request for a deployment, and based on some criteria or not, we would actually inject a sidecar using an initializer. So let's just go through, and before I go through, let me just show you. I have so this is in Kubernetes 1.7, and it is in alpha at the moment. So I have a fresh 1.7.4 cluster, and I get pods. I don't have anything running in the default namespace. And let me just show you a couple of background bits. Admission. So I'm on the master server here, and I just want to show you that I've had to enable initializers on 1.7 as an admission control. So we're opening up access to this, and also I'm allowing this admission registration alpha API. So if I do kubectl API versions, you should see that we have an admission registration API enabled. Now, with those two things enabled, we should be able to run through Kelsey's demo. So first we're going to deploy the Envoy initializer, and basically the first step to this is deploying a config map for the Envoy process. So let me go and show you what that looks like. So this is actually tells on the Envoy proxy how you want it to run. So there's some configuration details in there, and that's just deployed as a config map. Nothing special there. Next, we're actually going to deploy the config map for the Envoy initializer. Okay, so let's go take a look at that. Okay, that is not the Envoy initializer. It's under config maps. I'll show you it here. So we have a config map, and basically initializers are controllers. much the same as operators. They live as pods inside your cluster, and they put watches on resources, all resource types, even uninitialized resources. So resources that aren't initialized are actually in an uninitialized state and need to be initialized. So I can go through what that means in a minute. But basically, the API server, if there is an initializer config, it will go through the list and annotate the initializers that need to go through and service it, and they will all independently go and add the bits or subtract the bits out of the resources depending on what those initializers actually do. So this one, it's got a config in here, and you can kind of guess what it's going to do. It's going to add a container and a volume here, and some resource limits. So it's going to add the Envoy proxy here as a sidecar with some volume mounts, a volume, and some resource limits. So pretty much the controller takes a config map in that tells it what to actually do and modify on the resources. So we have deployed that config map. Go take a look at the next step here. And now we're actually going to deploy the initializer. Okay, so let's go and deploy that, and we'll pull this up. Now the interesting thing so that's the deployment, we'll pull up the Envoy initializer here. So this is the Envoy initializer deployment, which basically acts as a controller. So we will tell the API server as requests for specific resource types come in, we will forward them over to this initializer for processing. Now you may notice here we have initializers pending, so we're actually setting initializers to an empty array. So one of the problems with initializers is that they actually block before resource creation. So if you have initializers out there on resource types, resources need to actually go through initialization, and if there's nothing receiving, let's say all your initializer pods, this Envoy initializer died or stopped processing requests, resources would sit in an uninitialized state and would never get past it. So you need to make sure that as you're experimenting or thinking about using this in production, you want to make sure they're production ready, in that they're always up, because you can cause yourself a bit of a headache there. But we don't have any policy in place to say shoot it to an initializer anywhere else, but we're saying on this thing that initializers is always set. Don't ever go to initializer to get the initializer up. It's kind of a chicken and egg thing here. So what we should have, get pods, is the initializer is up and running now. Great. So we've deployed the initializer. Now what we're going to do is, there's a Hello World app here. Let's go ahead and deploy this. Deployments Hello World. So this is just a standard Hello World application here. Nothing special, just a standard deployment. So we've got that initializer installed. I did not type pods correctly. So what we can see is we have the initializer, we have Hello World. The important thing in here is we're one of one, so we have one container run in ready state in the pod. So it's a single container pod at the moment. So we haven't actually done anything to tell this initializer how to operate. So in the next step, we will create the initializer configuration. So let's go and kick that off. All right, let's have a look. So here is an initializer configuration here. Let's have a look. So basically, under this API, which we saw we enabled, we're creating, we have a new kind initializer configuration. We give it a name Envoy, and it matches Envoy-initializer under this namespace. So it's saying anything under the API group star, API version star, resources deployment. So any deployment, go shoot it over to the Envoy initializer. So the Envoy initializer will see its name. It'll basically, the API server will annotate this in an array 0 through n, and it'll put the name of the initializer on there. When the initializer sees it on the watch, it'll actually see that it has it, and if it's at the top of the array at position 0, we'll take it off and process it. If something else is there, it's its job to actually act on it and not the one. It'll only act on its name if it's at position 0 of that array. Okay, so now we're saying all deployments go to the Envoy initializer. So what we would expect now is when we go and do a Hello World delete, and we recreate it, we now have 2 for 2 running. So what has happened here, if I go and get this pod, kubectl describe that pod. So what we can actually see here is we've got a volume, Envoy conf, which is not in that hello world, and we have a container, Envoy, there. So the initializer has actually processed that resource request, padded out and added the Envoy container and the volumes to it, and then saved it. And it's gone past initializing, and it's now in running state. So there's one more piece of this demo before I round this out, is I'm going to go and delete both hello world example and the Envoy initializer. So this example, the initializer is actually set up with an annotation that says, I will only add the Envoy sidecar to deployment resources that have this annotation in them. So when I ask for hello world, I have actually got this annotation. There you go. So we would expect hello world not to be actioned, but hello world with the annotation to be actioned. So let's go and do this. Okay, so hello world, the standard one. We have the initializer running. No, it's 1 for 1, so the initializer has not added the Envoy sidecar. And now we're going to create another deployment here, a brand new one, but this has the annotation, and the initializer is configured to only add the Envoy sidecar to things with the annotation. So you can see this is working as desired right here. We have 2 for 2, we're in running state. Fantastic. So as I said, this is a great way to actually extend the Kubernetes API and another great set of features inside 1.7. Be careful, I will link some great docs out there, as I said, and Kelsey's put together a great demo. So thanks for that. And Ahmet here has a great blog on some gotchas and best practices, so I just suggest you read them before you start going down the line with getting this into prod. There are other subsets of features or different features that may do what you want, so take a look at pod presets if you don't want to go through the trouble of writing and running and maintaining your own initializer. Pod presets may give you what you need, and there's also some great blogs out there I'll link in the description. But thank you very much for joining. I hope this was beneficial. Cheers. Bye.